Points of inflection. We have this function, we want to find this specific point. And to understand how we can find points of inflection, we need to first understand a certain piece of info, perhaps. And that is f double prime, so the second derivative, is concerned with concavity. More generally, the second derivative is just the derivative of the derivative. So it's the rate of change of the rate of change. And from finding out what the rate of change of the rate of change is, we can tell whether the function is looks like this or looks like that. Okay, like that. Because then I'm still in the frame. So let's say you're here, you know, for example, that your second derivative is, let's say it's positive, then you have a smiley face. And if the second derivative is negative, then you don't have a smiley face, you have a sad face. But again, this is not important at all for our question. What is important is what happens in the middle. So when you're in between the switch between concave up to concave down. So it's this switch in the middle. And so here is where inflection happens. And specifically, it happens when the function is not positive or negative. So the function needs to be 0, right? And by the function, I mean the second derivative. So the first thing you need to do is to compute f double prime of x, and then find its roots. So that is your recipe to find the point of inflection. So perhaps you can try to pause the video and do that. And here we'll just proceed with the standard setup. So the first thing I would do, I would find the second derivative. To do so, I need to find the first derivative. Now, e to the x is an easy function to take the derivative of, but you need to take care of the composite function. So it's e to the x composed with minus 4 over x. And so you need to multiply by the derivative of the inside function. So it will be 2e to the minus 4 over x times the derivative of minus 4 over x. And the derivative of minus 4 over x is it's 4 over x squared. You can check this yourself. Again, this is not the core focus of this tutorial, to find derivatives. Then in that case, f double prime of x should be a little bit more tedious. Just a little bit. But we can still achieve it. It's going to be the derivative of that. So I'll apply the product rule. I'll get 2 times e to the minus 4 over x squared over x times 4 over x squared all squared. This is because I fixed this one and I took the derivative of that one. So I got 4 over x squared again, in short. And then I fix e to the minus 4 over x, and I take the derivative of 4 over x squared, which is minus 8 over x cubed, if I'm not mistaken. Yes. then I just set this to be equal to 0. So that this is only the first step. This is only the first step in my procedure. But I still need to carry out the second step, which is finding the roots of this thing. How would you find the roots of this thing? Well, you would start by simplifying it, at least. So I see here that we have a common factor of e to the minus 4 over x times 2. So I'll take it as a common factor. And since we're adding, so I'll just do like this. Maybe I'll also factor out 4. I'll even factor out 4 over x squared. Even better, I'll factor out 8x cubed. You'll see why in a moment. So what I've just done here is that if I raise this to the power of 2 and raise this to the power of 2, I get here 4, and I get 16. So I can actually take out 8 over x cubed, and then I would have here a minus 1, and here I would have 2 divided by x. And I'm getting very, 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 very close to the solution. So notice that just by some simple simplifications, and before even saying let f double prime of x be equal to 0, I'm very close to finding the solution. Because if I set this to be equal to 0, this is always greater than 0, you know, because e to the something is never negative. And this would never be equal to 0. So it can be positive, it can be negative, but it will never be equal to 0. So this must be equal to 0. So if f double prime of x is equal to 0, then probably this is the part which is equal to 0. And this should not be too difficult to solve. I mean, if you just plug in minus 2 here, you get... No, if you just plug in 2, you get 2 over 2, which is 1. And 1 plus negative 1 is 0. So this is the root of the second derivative. So it looks scary, but with some proper simplifications and a little bit of patience, then you can make progress on the problem. So we know that x is a point of inflection. X is equal to 2. And that is actually all we need to find out. So I don't think the exercise asks for anything else.